Hello, I'm Yakesh Pope. I'm the team leader for the Nautical team for SIH, right? The selected problem statement is SIH 1658, and the problem statement title is Development of a Versatile and Fast Algorithm for Optimal Ship Routing. The theme is Transportation and Logistics, and the category is Software. Our team ID is 26756, and yeah, again, we are Nautical underscore 24. So, here is a brief about our idea. What we are targeting is from our solution, we want to optimize the fuel efficiency, right? And create sections like here you'll see like we are creating the blue and the orange sections, right? These are the different sections so that our ship travels from a safe path. The coastal navigation, again, this we have to take in to this account with real-time sonar data, right? We have to highlight this. Then deep sea navigation. So we have to know if in deep sea the distance is less than 600 nautical miles, which should be covered by plain sailing, right? And again, the weather data analysis. We we thought of using image recognition for weather data as well, right? Based on the charts that we have, like these are the weather data charts, right? So based on this, route can we help ships route directly using image recognition? That was one of our approach. Passage plan should be made after consulting the tide tables, notice to mariners, or ocean passages of the world, meteorological predictions, and mariner's handbook. So these are number of things that we found out after talking to some marine officers, some navy officers actually, and then the preliminary route planning, right? The route that is suggested, right? And then it will be modified by the master or the ship captain, right? So yeah, we are aiming to have a self-improving model by applying reinforcement learning techniques. So here is the basic technical approach that we will be following, right? In text type, we have Postgres, Flask, Python, Keras, TensorFlow, Scikit-learn, TypeScript again, Leaflet for chart plotting, and next.js for as our full stack framework. Then basically what happens is we'll get inputs for the origin and destination from the user. Our algorithm will first classify like is it a coastal navigation or deep sea navigation. These are two different methods, right? In coastal we have bathymetry and real-time sonar data, and these are all the parameters that we found will be the features for our model, right? We have to eliminate the area, like for that the blue area, right? We have to eliminate that. We have to route as much straight lines as possible so that the ship travels in a straight path, and thus saving time thus saving time and fuel, right? Then in deep sea navigation we have the following parameters, and based on the permutation of all these parameters we found a compound route, and based on this we give the like routes to the user, right? And on the higher level architecture, this is the use case. The users can sign up and go to our website. For now it's a web app that we're building, and on EC2 it will be hosted on EC2. We have our application where the user can browse map, find routes, and from data providers we will have weather data and ocean currents, right? From find like to find route we'll have to provide the journey details, right? And when we provide that, the user will get optimal route suggestions, but on the back end this we will fetch all the data from all sources. We'll apply deep learning logic and also reinforcement learning to get the optimal route, and then we'll get a confirmation from the master or the ship captain, and then the final routes will be mapped. So next is the feasibility and viability, right? So it it's a very technical readiness. The real-time sonar, bathymetry, and image recognition models are established and can be integrated, right? Data availability, there are many sources of oceanographic and meteorological data that are already provided by a lot of third-party providers, right? Implementation complexity. All the navigation charts that we found out were frequently getting updated on like on average on a monthly basis, right? And cost consideration is something that is a very major factor here because uh, there are upfront costs, and the data, even the data that we have for all these charts is pricey. All the charts are paid. The free data isn't available for ship routing, right? So that's a major blocker in this industry. Then viability, economic benefits, right? We will have optimized routes leading to significant fuel cost savings and reduced risk of costly accidents. Environmental impact will have lower fuel consumptions, right? Scalability, this system can be scaled since it's an web app based on cloud, right? Impacts and benefits, there is a market demand, right? As the fuel price increases, it becomes more difficult for ship companies to defend their profit margins. The strict environmental regulations creates high demand for such optimization algorithm. So this optimized route analysis will lead to very significant fuel savings, operational cost will be reduced, and profits will be increased, right? There will be an enhancement in navigation for deck crew, right? In storm and hazard scenarios, since we are getting the weather data, we'll be able to predict them, right? The real-time sensor data integration, sensors installed on the ship will also provide the barometric readings, right? So that will be inculcated in our algorithm as well. Then these are the references and research. We actually talked to all three of these officers, right? We took their input. One of them was from currently deployed Navy officer who is serving in the US, the UK Navy, sorry. And yeah, so we got a lot of insights from this, and we know the pain points that the current Navy system, the current sea routing industry is facing in India, especially. And these are the research paper that we referenced in chart reference and website. Thank you, and